Hey, welcome to the SKALE Labs Pirate Radio. I'm Anna. I'm the co-host of another podcast, Zero Knowledge. Today, I'm here on behalf of SKALE Labs, and I'm here with Konstantin from SKALE. Konstantin, what is your role at SKALE?
Yeah, so I'll tell a little bit about myself, also a little bit about how we started SKALE. So I'm the co-founder and CTO of SKALE. I have also a really good friend of mine. He is also co-founder. He is the CEO. He is the business guy. I am typical tech guy. So we started SKALE about now 4 years ago. And at that time, I had a startup which was doing big data. And so big data, AI, all of these things. And this startup didn't really go so well. So we were trying to compete with Google and Amazon.
Hard.
And so the startup was going down. And pretty much at the same time, Ethereum happened and crypto and all of the Vitalik Buterin and DevCon and things. So what happened is that our VCs told us, instead of shutting down the startup or selling it, go and do crypto. And we had this crazy turn from big data and AI to crypto.
Whoa.
And it was in around 2017. So the way it happened is that I flew to DevCon 3, I believe,
Cancun?
in Cancun.
Yeah, I was there.
Oh, I see. And I didn't even have a badge. So one of our VCs gave me a badge. And I just get there. And the moment I got inside DevCon, I really clicked. I understood that that's really kind of a lucky moment because there was so many things happening and the industry was exciting. And I understood that it's just, for a startup, it's super important to have the right time. And I really didn't know what to do. And got back, and the VCs just gave us some money to think what we need to do.
To pivot into blockchain.
To pivot into blockchain.
So then is this company, you said it's 4 years ago. Was it 4 years ago?
The pivot happened 4 years ago.
That's when you shifted?
That was when we shifted.
How old was the company before
that?
About
2 years.
Okay.
So we got seed funding from 2 pretty famous VCs in Silicon Valley. One of them, Floodgate Capital. There's the same fund which started Twitter and Lyft and some other. And another VC, Signia Ventures. And we were doing big data. Essentially, it was a big data platform. And then we pivoted.
When you shifted over, did you bring the team with you?
Yes.
Okay, so this is a long-standing team that you have.
Exactly, and
cool.
That's actually one of the reasons was that people that do AI and big data naturally know lots of mathematics, and so we had very strong guys.
I bet.
And we shifted.
Tell me, I think we should find out now, what is SKALE? What is this project? So you did the pivot. What did you become?
So basically, when we try to find the problem to solve. But because every startup starts, you need to find the pain, the problem. And at that moment in 2017, the pain was pretty obvious. It was scaling, right? And that's why it's called SKALE. We've been looking for a name, and it's an obvious name. So we wanted to scale Ethereum. And the reason for Ethereum was that we decided that it was too late to start a different blockchain, that once a particular technology, like a programming language or platform takes over, it's impossible to kill.
So you made a conscious decision then, because at the time, 2017, there were tons of projects fundraising to build new L1s.
Right, and even now, and I think we're contrarian. I've been telling for the last 4 years that it's not viable long-term to have a blockchain which is incompatible with Ethereum. I think these blockchains exist now, and some of them are medium-term successful, but we still have the opinion that long-term, the way the industry is going to evolve is that Ethereum ecosystem, not just Ethereum mainnet, but Ethereum ecosystem is going to grow, and there will be different chains, different technologies, different people, but just as a compatible technology, that was our bet. So then we decided, okay, we need to be Ethereum compatible, and the second thing we wanted to do was to do Web3. So we really got excited about ideas of economy, like decentralized economy. If people can lend each other money over internet, if a guy in America who is retired and getting 0.5% on his savings account, and a guy in Europe somewhere that wants to start a business, connecting these people without intermediaries.
Yeah.
Or another idea was like a decentralized Uber, like a version of Uber where drivers get everything, like there's no fee. Right,
or the fee goes to the driver.
Or the fee goes to the driver
Yeah.
and the token. So these new economic ideas where there's no monopoly. And I think that was our vision. So we wanted to do Web3, which naturally led us to the point that we need to Ethereum to do websites.
But you also must have realized, like, we want to build Web3, but back then it was like, but what can you build on Web3 at the time?
Exactly.
And what's missing?
Exactly. And our idea was actually very simple. You know, it's usually very simple. So the idea was that what's missing is a web server, and we just added to the Ethereum software, we added a well-known web server which is called Nginx. So our chain is actually compatible with Ethereum, but you can actually, inside the Ethereum virtual machine, you can host files and images and music and videos, and it's a web server. So with Scale, you can literally have the same type of website.
Cool.
You can take Uber, you can take Airbnb and move it really fast. So that was another idea. And then the last thing, we wanted to work fast. So we wanted a faster proof-of-stake consensus. And we spent probably like 2 years trying to research how do we build a provably secure consensus, a mathematically provable consensus. And I think currently we are some of the few projects where the blockchain is actually mathematically provable from the beginning to the end.
Cool.
It's also fast.
Has it been like formally verified? Is that what you mean by that, or is
we
it?
may actually do it sometime in the future. What we mean now is that you can write a paper about Scale, which we actually are planning to do soon, and submit it to a refereed journal and actually have it passed. We don't have any holes in our mess, so we don't hide anything, and also open source. So the way we did it is not by doing this stuff ourselves, but we collected actually lots of algorithms in academia, and lots of cryptographic algorithms, and I'm going to talk about them. But in particular, we're doing lots of threshold cryptography.
Cool.
We are doing threshold signatures. And we are doing also lots of provably secure networking algorithms, such as binary consensus algorithms. So our blockchain is actually sending lots of messages, receiving messages. But the idea is that ultimately, if less than 1/3 of our guys are bad, we are provably secure, meaning that the blockchain operates, it's Ethereum compatible, and it's secure. But then the last thing is we don't have a single blockchain. We actually have an internet of blockchains.
No way, really?
So in our system is actually based on Ethereum mainnet, and the way it works, you go and you want your own blockchain, and you go to Ethereum mainnet, and there's a smart contract on Ethereum mainnet, and you tell this smart contract, I want a blockchain. And so this contract picks random computers from our network and runs our version of Ethereum on it. And then you have your own Ethereum blockchain. So this is an internet of Ethereum compatible blockchain.
Okay, so it's not a single side chain, it's multiple. And by the way, I know the term is loaded. Actually, so do tell me, let's kind of take, I want to understand how you see yourselves. Is it a side chain? Let's start there.
It's, you know,
is it side chains, I should say?
If you go and read the paper of Satoshi Nakamoto, whoever this person is or this organization, actually I believe it's an organization, but anyway. So if you read the papers of Satoshi Nakamoto, you see that, I mean, it's trivial, right? Probably in one of his first papers, he understands that, and his messages also, he understands that a single blockchain cannot run everything. You have many people in this world, right? So you need to have many blockchains. It's unavoidable. It's a very trivial statement. So he understands that the world of the future will have many blockchains, and people will run them. If people want to call them side chains, I prefer to call them up chains, application-specific chains. Because what we want to do, we want to run on one of them, we want to run Uber, on the other one, we want to run Airbnb. So, but if people want to call them side chains,
It doesn't offend you.
we don't care.
Okay,
Really,
but what
but
you're describing, so I want to go back to what I was about to say, which is that I thought, actually, in entering this interview, that SKALE was a single side chain. But what you're describing to me is that it's not.
Many.
It's actually multiple, and it's almost like instances of side chains, right?
Blockchains. And then let me bring another point. People talk about internet computer. People say Ethereum is a internet computer or something
Although
else.
I think that language for Ethereum has like ebbed and flowed over the years. Other teams have taken it.
There's no internet computer. There are internet computers because if you studied computer science, you understand that you can't run things on a single computer.
Yeah.
In fact, in 60s, people did try to run everything on a single computer. And the vision of the world in the 60s was this super duper huge supercomputer that runs everything. If you've seen like the Terminator movies, whatever, but it didn't work out. Actually, the world is internet of computers, and it's actually very important. So you have for these blockchains, they have to be weakly connected. The same way computers on the internet are weakly connected. It makes the entire system reliable.
Weakly connected.
Weakly connected. So our stuff is internet computers, if you wish, or blockchain computers. It's just, in reality, it's very simple. Just many copies of Ethereum that work fast, that can host websites, and they can interact.
That's
the same as on the
interesting.
internet.
And each one of those instances is EVM compatible.
Absolutely. Actually, we forked. By the way, thank you very much to the creators. There's a project called Alice or CPP Ethereum. It's a C++ version of Ethereum, which was, I think, created by Gavin Wood, one of the co-founders. He is a really great programmer. So we forked his code and changed it a lot. Thank to him for his contribution.
I think actually I know another dev that worked on that one. There's
it's a good thing. So we're running the same Ethereum virtual machine as other guys, but it's like EVM plus because we added files to it, which was really important, and we also added the web server.
So you didn't fork Geth. You forked this other client.
Because, as you know, in computer science, the only language which matters is C++, and all other people, they just don't know C++, and they invented other languages so people can program. But C++ is the only language which allows you to program fast, and it's like sky is the limit. You can do anything you want, and all other languages are just written in C++. So we selected C++ because we wanted to be really, really fast. But we are currently the world's fastest provably secure blockchain. There are blockchains which are faster than SKALE, but they are not provably secure. It's like if you take a car and if you take brakes out of it, it will run faster, but it won't brake.
Explain. When you say provably secure, does that have something to do with the consensus side of it? And so you had said it was POS.
Right.
So I want to kind of understand. You forked the C++.
Added
that is
RPO.
the client, and then you added to it. You created it, instead of it being a proof of work, you pulled out the consensus, you put in POS.
Right.
And now you're saying it's provably secure.
Right, it's our proof of stake.
Is that something like instead of 2/3, it's 100%? Like voting?
No.
It's not that.
Many blockchains that run today are not secure even if one validator becomes malicious. So
I always thought it was sort of like you have to have, 1/3 is correct in order for it to be. But there are some where you say that one validator being malicious could be problematic.
Basically, you have Tendermint. You've heard about Tendermint.
And that's probably the one I know the best.
Tendermint is almost secure. I mean, there's some people in academia that found some small holes in Tendermint. And Tendermint wasn't designed from the beginning to be mathematically clean, but it evolved, and it's pretty secure. Other blockchains that claim to be running faster, the way they do it is just by actually, creating a trade-off and not being secure or not being mathematical. So many of them, which I won't name, I did name them in the past on Twitter. It didn't work well.
If people want to find out, they can.
Right, yeah. So people just, it's actually very simple. If you have a blockchain, just look if it has a paper or it has some mathematical justification. And so unfortunately, what happened in the industry was that because people wanted to have these claims, we have 1,000 transactions per second. We have 10,000 transactions per second, which actually the claim doesn't make any sense because if you know in computer science, if you have faster network and faster computers, you can run anything, any single thing at 1 zillion transactions per second. But they were making these claims to investors were investing in them.
Yeah.
And as a result, they were pushing things to run faster at the expense of security. But the point is that validators, for the most part, at least now, are not really malicious. So many blockchains where a single validator could like steal all of the money and do bad things, they still run.
Okay.
At Scale, we do things differently. We have our niche. At Scale, if 1/3 of validators, less than 1/3 of them are bad guys, we can prove that it will actually never be bad.
But are you not using Tendermint?
No, we actually have our
what
own.
What is it? Yeah, tell me a little bit about that.
Yeah, so we actually have been trying to build a framework, trying to understand basically, the best way to understand something is to teach it.
Okay.
I think Feynman, there's a American physicist, he said this. So we tried to understand this. And when we started, we couldn't have a clue about how it works, the blockchain. And we were reading papers, and every paper was using its own language.
I know, and every network has a different language.
And we didn't also have it. So we actually, after like many trials and errors, we came up with a very simple framework where we split the blockchain into stages.
Okay.
And if every stage is secure, there are 7 stages. And actually, I'm going to have a talk about it during this conference. The stages are simple. And if every stage is simple and secure, the entire thing is secure. And for every stage, we just take algorithms from academia. So we basically created this kind of a framework. And so we even have like a backronym for Scale. It's a standard kit for asynchronous ledgers.
Okay.
It's a kit, so it's not just a single consensus. It's a family of consensus. Now we're able to do it.
Neat.
And other people are welcome to modify our stuff. And it's kind of plug and play in the sense that you can use this algorithm, that algorithm, and it works.
Can you tell me a little bit about like the finality of this consensus mechanism? Because I only know this a little bit from like the Polkadot grandpa and the way that finality works there. How does yours work?
Yeah, that's a really good question. There's like several fundamental problems if you want to build a blockchain which is secure, right? One of them is finality, and the other one is data availability. I'll tell about this also. Finality just means that, you typically have the situation where block proposers propose blocks. It could be one proposer, 2 proposers, whatever. But at some point, the blockchain needs to decide which block proposal wins.
Yeah.
And it's a multi-valued problem potentially because there could be many proposals. So in mathematics and computer science, this thing is called multi-valued consensus.
Okay.
Consensus is just when nodes agree on things. Now, the point is that this multi-valued consensus, there's another simpler problem, which is called a binary consensus, or something that people call like Byzantine generals problem, where there are like generals in the army, and they decide whether to attack or retreat. And they have to make a common decision. And the difficulty comes from the point they are geographically in different places and only can communicate in pairs. They can only call each other. Or they can only send a horse. So if people are in the same place, consensus is very simple. Like people just vote. But if you geographically distribute them and give them like each of them a mobile phone or a horse with like a guy who like brings the letter, it actually becomes mathematically super hard. But there are actually solutions. Starting from 1982, in computer science, there was a progressive set of solutions solving this problem, and the algorithm becoming better and better and better. And the current algorithm is pretty fast. We're using the algorithm from University of Nantes in France, actually, and the guy invented this algorithm, and it uses cryptography, it uses threshold signatures, but works really fast.
Cool.
So our consensus comes from this academia thing. Now, the second problem, which is super important, is data availability.
Yeah.
Because another bad thing that can happen is that a block proposer may become malicious, and the block may win, and then the proposer may withhold the block, and the chain will get stuck. So that's something which is called being live. liveness,
Yeah.
right? So to protect against this, the block proposal has to be widely distributed. There has to be a proof that the block proposer distributed the proposal widely before it proposes. And so if you solve these two problems, and actually both of the problems involve threshold signatures, because
is where
for data availability, you just need to have a threshold signature that you distributed your proposal to 2/3, and then the problem of liveliness and getting stuck is removed.
Got it.
So when we solve these problems, actually become simple. So the funny thing is that after we did all of this stuff, things became progressively simple and simple and simple.
Really?
Yeah.
And yet it sounds like there's a lot of complicated stuff to go through to get to it.
But we actually have a framework to explain in a simple way. So I welcome everyone. There will be a talk.
Yeah.
I think the second day of the conference, I will have a 40-minute talk about this thing.
I think by the time this video comes out, hopefully that video is also out.
Yeah, totally. Okay.
Cool.
Okay.
Maybe we could link to it.
Okay.
Okay, I have a higher level question that I want to kind of bring it back to the topic of this whole thing, which is cross-chain and like how communication happens across these things. So you talked about the multiple sort of blockchain instances. First question is, where does this validator community live? Does it live on each one?
So this is huge network. Imagine the network of many computers, and we want in the future, in the long-term future, we want this network to be like 1 million computers.
Yeah.
And we understand it's not going to happen fast, but like 20 years from now. Imagine a network of 1 million computers. Anyone can become a validator. You can put your computers on the network, your computer.
But wait, by this do you mean like the computer that runs the instance is the validator?
Validator can put 10. The difference between us and them, our validator can run 100 instances, 2,000 instances.
Okay.
We have a network with many. With like Tendermint, each validator runs a single machine. In our case, a validator can start with 1 machine. We have validators now running like 20 machines. In the future, if we do want to have like a decentralized Google, Google has probably like 2 million computers, and Amazon has 6 million. We want every validator to be able to run many.
Got it.
And then this network, you come and say, I want a blockchain, and we pick randomly, cryptographically randomly, we pick these guys.
Got it.
And they run a blockchain from you, and they also rotate from time to time.
But do all, let's use the example. Say you have 30 validators, and then maybe you have a lot more, but let's just use something
Currently
simple.
we have like 50, I think.
Okay, so let's say 50 validators. Each one is running the client, and they're using that to validate the POS system.
Right.
But then, right now, they're using a computer to run that. If you wanted to deploy one of these instances of a blockchain, you would do it on one of their computers.
Not one, but we would randomly pick many out of the network.
It would be a collection of
theirs.
Okay.
And a random collection. And also in this collection, we rotate them. If they stay there forever, at some point they can be bribed. So from time, it's like a hockey. You're a Canadian, right?
Yeah.
So,
I
you understand hockey.
I do know hockey.
There are 5 people, and the other people come. And the point, that's very much what happens at scale. There are like nodes that run your blockchain, but at one moment, one guy just jumps over the fence, it's called in hockey, and the other guy comes. So we rotate them.
They rotate, yes.
Because we don't want them to be there forever, otherwise they can be like bribed, whatever.
Yeah.
So that's the idea. And it's actually the simplest thing you can imagine. We didn't create anything complex. It's not our crazy thought. It's just the simplest way we could build this internet of blockchains. We tried to find the simplest solution and the most straightforward.
So now I understand kind of what that looks like. How do you bridge? So it's bridged to Ethereum, right? Like, is that the first? And actually, is Scale a standalone, or is it made out of smart contracts? Does it live on top of Ethereum, or does it live next to it?
That's a great question. So basically, Ethereum is expensive, as everyone knows.
We all know this,
right?
yes.
It's got a little less expensive recently, like last couple of weeks, but it's expensive. But it's very secure. And so our idea was everything in our network that we could put on the Ethereum mainnet, we didn't have to code ourselves the security. So all of the management of our network, the management layer, is on Ethereum. When you come to us and you pay Scale and you want your blockchain, you talk to Ethereum smart contracts. These smart contracts, the mainnet, will pick those computers we just discussed, will charge you. So all of the management of your blockchain will actually happen on Ethereum. Think about Ethereum like a boss for Scale, you know.
Okay.
And they're like, think about like Ethereum as the boss, and the workers are actually on Scale. So
Okay.
the guys who run chains, because we need lots of computational power on chain, but the bosses are on Ethereum.
All right. So is it
And-
something like some of the rules of the actual way that you would build these blockchains lives on Ethereum
Exactly.
in a smart
exactly.
contract?
Exactly. So that's
Okay.
exactly everything which is cheap, which is actually infrequent enough, because when we
deploying a new blockchain,
Right.
It only happens once in a while.
people can pay for
Reshuffling
it.
the
Exactly.
validators?
Happens,
Is that-
it also happens rarely.
Okay, so that could also be
You can
written
also
into the
down
contract.
so everything which is we could put there.
Yeah.
Currently, I think it costs you probably like several $1,000s in gas. Maybe like it was up to $10,000 in gas fees to get your blockchain, but it's actually okay.
Okay.
For applications.
What about computation and execution? Is
So
that
computation
all
happens. All of it happens on our network.
on your POS
On our
network?
network. And our network, we actually want people in the future to run bare metal servers, but in the meantime, we let people do things on AWS because people like AWS. It's super expensive. Some of our validators, the smart ones, already moved to bare metal because it's like 10 times cheaper to run. In our case, the economy is important because for every computer, they get paid every month in Scale tokens, but then they have costs. So if they move to bare metal, it's much cheaper, and we hope this natural innovation to happen and then move to actually cheaper computers.
Does the validation also happen through a smart contract, or is that happening on the
the
native
validation
chain?
happens? We call it decentralized validation. They monitor each other.
Okay.
If you run a computer or a node on Scale chain, you also monitor 20, I think currently 22 nodes, and it's also shuffled. So everyone is monitoring everyone else, and so essentially we're like creating this like decentralized AWS. But the service, how do we reach the level of service of AWS? The way we do it, every computer monitors every other computer, so it's kind of a community like policing. And then the statistics gets reported to Ethereum mainnet. So if your quality of service is good, you get paid. And if one of the metrics is not good, then you will get punished, but not getting paid. So we're creating this community that kind of self-manages itself.
Got it.
And so that's pretty much the idea.
How does it bridge to ETH?
So
How do you move, like,
Yeah.
when you talk about deploying a new blockchain, are you imagining those as like standalone things, or do you see
connected.
interaction
Yeah,
between
I'll
the two?
tell about it. So basically, if you think about internet, right, we're just copying internet. What is internet? Internet is just a set of computers that can send messages to each other, right? We are sitting here, maybe we are streamed, network packets are going from this computer to through series of computers. So that's actually very simple, and that's how internet was built. So what you need, the only thing you need, like for all of this, like Uber and Airbnb and whatever, and video, the only thing you need at the low level is being able to send a packet, a message from point A to point B. So we're literally copying internet. In our system, you are able to send a message from any blockchain on Scale to any other blockchain on Scale, and from any smart contract to any other smart contract. So it's also an extension to EVM, but in our case, for any smart contract can send a message to any smart contract on any other chain, and also to any smart contract on ETH mainnet. And the security of it comes again from threshold signatures. So it's a committee. So when you want to send your message to ETH mainnet, or you want to send a message to another chain, a committee signs the message using a threshold signature, and on the other end, this signature is checked. So all basically, the threshold signatures really are used heavily in our system.
Cool. Would you still say that there's like a bridge between those things?
I mean,
because like you described this threshold cryptography, which, by the way, is a topic that I want to eventually dig into deeper. I don't think we have time for it today. But yeah, like how would you describe this bridge between Ethereum?
So it's a bit of a different bridge. What people call a bridge, I mean, I think bridges which people currently use is usually like some guys running a computer, and this computer is a bridge, right? In our case, there's no bridge. It's more like a collective. There are two chains, right? When you want to send a message from your chain to Ethereum, 2/3 of computers on your chain sign this message,
Okay.
and one of them just pretty much transmits this message, just passes it. And
Got it.
so there's no like a dedicated bridge. It's just a collective. If let me give you an example. Let's say you have a collective of people that want to send a document
Yeah.
to the US government, whatever, or to another like collective of people. They all just sign this document, 2/3 of them sign, and one of them goes to the USPS, whatever, and drops the letter. And if this person is sick, the other person will go and drop the letter. So it's actually, there's no bridge, it's just them collectively signing and transmitting.
But what you're talking about here is messages, sending messages to the mainnet. What about sending tokens?
Money. Now let's talk about, it turns out that if you can send a message, you can send anything. I'll give you an example. Let's say we want to create a machine that moves money, cash, US dollars, from America to Europe, right, to Paris, right? The way we could do this machine, there would be like two machines, a machine in America and a machine here in Paris, and you would stick your like $1 bill into the machine in America, and this dollar bill would get burned inside the machine, and there will be a message, a secure message, just sent over internet to the machine in Paris,
where one gets minted.
And it will be printed, right? So you see from this very simple example that all you need is internet is security, because if the message is not secure, you can say you burned, but you didn't burn anything, but you print. So what we use and what pretty much everyone else
the
does.
messages have to be correct, because you
Secure.
have to for sure show that like the correct action has happened on one end of this bridge.
Exactly. And if the message is not secure, I can burn $1 and tell you I burned $1 million. And so the bridges that exist now, the security of them, the problem is that if the bridge is compromised, the chain, the side chain is fully compromised. If any of the side chains that exist today, if no one knows, I don't know how these bridges work, many of them are obscure. But if this computer is compromised and the message is compromised, you can print 1 million tokens on this chain, and the chain will be pretty much like dead.
Would you say that some of these, like I've always heard this term, like it's a multi-sig controlled by like 3 signers between these huge volumes of value? Like, are they like, and this is sort of talking about like other projects.
So the problem is that it's unregulated, right? And these bridges, they are obscure, they're not open source. For many of them, if you go to GitHub, you don't even find the source code.
Wow.
People can say anything. I personally don't know how they work. I tried finding.
And you tried to get into it.
And I don't know.
That's weird.
I mean, the simplest way to get this thing work is just to have a single computer and a guy with a key and the guy controlling everything. But then there is a problem about the security of the guy. Or the guy may just go to islands and like. And these things happen in the past, right? People just pulling the rug. So we don't know, but we don't really talk about this because we care about scale.
Yes.
And our stuff is actually open source. It's very simple to understand security. You need to break SKALE chain in order to break. It's possible. You know, as everything in computer science, security is breakable, but you need to break a sufficient number of SKALE machines
for that to
in order for this to happen.
So yeah, I think I have one last question to ask you, because I'm getting indications that we're almost at time. What do you see as a kind of cross-chain future? Where does SKALE live within that future?
I mean, I think we hope that things will go in the direction of decentralized Uber and decentralized Amazon. Blockchain is a little bit speculative nowadays. People just create like Uniswap clones on one chain, another chain. It's a bit of a speculative phase. We hope that this phase will naturally subside, and the future is that we really think that the next big thing is Web3. So we hope, and actually we're organizing, if anyone wants to join, we're organizing a pre-Y Combinator camp for SKALE.
Cool.
So anyone who wants to have like a huge idea, we have really great VCs. We have Floodgate Capital, which, as I mentioned, funded Twitter and Lyft, and they're looking for big disruptive ideas. So in October, there will be this camp where SKALE engineers and also people who think about startups. You don't even have to have an idea. It's like pre-idea stage. we hope that these things will happen cross-chain. And so cross-chain, my thinking is that that's like one chain will have decentralized Uber, another will have decentralized Airbnb, and you'll have the experience of what you have on Web 2.
Cool.
And that's actually what we think is what we hope for.
This is Web 3 past the AMMs and finance only.
All right, exactly. That's what we have. What will happen, and it's much more exciting. AMM is also exciting. It's really interesting.
Got people excited.
But this is much bigger future. I
cool.
think.
Thank you so much
for
the
your
interview.
questions.
Thanks for watching.